welcome to lesson 42. We're going to be learning about short division and divisibility by 3, 6, and 9. Now, we have done long division already, and short division is simply long division but doing more of it in your head. So, I'm actually not going to require you to use short division. This is only for those that are comfortable with it and that have already memorized the steps and are feeling very confident in their work with long division, meaning very minimal mistakes. So I'm going to show you how to do short division anyway for those of you that are very comfortable with it. And if you aren't, just go ahead and continue to do the long division steps because it's the exact same process. So long division would say 56 divided by 4. 4 goes into 5 one time. I multiply 4 times 1, which is 4. That's what I subtract, and then 5 minus 4 is 1. Bring down the 6. 4 goes into 16 4 whole times. I'm done. Short division, exact same thing, but I'm doing more of it in my head. Notice I have 4 goes into 5 one whole time. And I know that 4 times 1 is 4. When I subtract 5 minus 4, I have 1 left over. So I carry this leftover 1 up on top next to my 6 because these two numbers are what I'm looking at next. 4 goes into 16 4 whole times. Notice I didn't have to write any of the steps down. Exact same thing. I get the exact same answer. One is just doing more of it in your head. It's teaching you a little bit of a shortcut because, of course, mathematicians are lazy, you know. It's teaching us a little bit of a shortcut to do it. However, all I care about is that you get the correct answer. So whether you feel comfortable doing short division, that's great. If you feel only comfortable writing down the steps and you need to continue to be neat and organized, please do that as well. I will not count off for not using short division at all. So example 1, you may use short division or you may use long division. I will leave it up to you. 842 divided by 5. I'll show you the short division way. 5 goes into 8 one whole time. If I subtract, 5 times 1 is 5, so if I subtract 8 minus 5, I'm left over with 3. Bring my 3 here next to my 4. 5 goes into 34 6 whole times, and 6 times 5 is 30. 34 minus 30 is 4, so then I have 42. How many times can 5 go into 42? It goes in 8 times. And 8 times 5 is 40, so 42 minus 40 is 2. That's my remainder. So remainder 2. Notice I did this all. I just had to write 2 separate numbers up here, and I could show you the steps. It would be, I did minus 5 for long division, left over with 3, bring down the 4. 5 goes into 34 6 whole times, minus 30. 34 minus 30 is 4. Bring down the 2. 5 goes into 42, 8 whole times, minus 40, and my remainder is 2, right there. So I did the exact same work. I can do it using short division or using long division, whichever you feel comfortable with. All right, now we are also going to be looking at divisibility rules. We've already done, remember, divisibility rules. If something is divisible by 2, which we already learned, that means it's an even number. Every even number is divisible by 2. We also looked at 5. Every number is divisible by 5 if it ends in a 5 or a 0. And we also learned divisibility by 10. Now, divisibility by 10 means that 10 can go into every number that ends in a 0, and that means a whole amount of times with nothing left over. So we're going to learn divisibility rules for 3, 6, and 9. So for 3, if the sum, meaning sum is addition, of the digits, so if I were to add, for example, 8 plus 4 plus 2, that's the sum of these digits, is divisible by 3. So a good example may be, let's see, a good example would be 438. Let's just write that down and try that for now. 438. 4 plus 3 is 7, and 7 plus 8 is 15. So the sum of my digits is 15. That's adding my digits out of my one whole number together, and it equals 15. So what this is talking about, 3 can go into 438 because 3 can also go into 15 an even amount of times. 3 times 5 is 15. So this is what this means. That means if I do 438 divided by 3, I will not have a remainder. I already know that off the top of my head. This helps for division as far as checking your work, seeing if it makes sense. And I know if I did end up with a remainder, my answer would be incorrect. So another rule for 6 is if the sum of the digits is divisible by 3 and even, or if it's divisible by 3 and 2. Is this number divisible by 2 also? It is an even number because it ends in an 8. 8 is in the ones place, that's an even number. And it's divisible by 3 because the sum of the digits is divisible by 3. So that means this can be divided by 3 and 6 evenly with no remainder. I know this is a lot to keep track of. I want you to go ahead and write these divisibility rules down though, because this will help you remember, at least looking back in your notes and checking, because you will be seeing these quite often. Then we also have divisibility of 9. Says that if the sum of the digits is divisible by 9. You've already known this with your 9s trick, unconsciously probably, because whenever you have 9 times 9 and you use your fingers as far as the finger trick and you put down your 9th finger, which would be right here, how many fingers do I have up all together? I have 9 fingers up because 9 can be divided by 9 evenly. So same goes for any other number divisible by 9. If I have 9 times 12, that's 108. 8 plus 1 is 9, and 9 is divided by 9 evenly. Therefore, 108 is divisible by 9. Another example, if we were to look at, if we were to look at 438 like we used before, answer's 15. Can 15 divided by 9 evenly? The answer would be no, it can't. So therefore, this cannot be divided by 9 evenly. We already know that. We would have a remainder left over. So, for example 2, this problem is asking which of these numbers is divisible by 3, 6, and 9. I want you to go ahead and write down the answer that you think it is. Let's look at them all together. 456. So if I had 4 plus 5, that's 9, and 9 plus 6 is 15. So that's the sum of my digits. I'm just going to write it down at the bottom here. Let's check the sum of my other digits. 3 plus 6 is 11. 11 plus 7 is 18. And C, 5 plus 7, let's see, 5 plus 7 is 12, and 12 plus 6 is 18. Had to double check that. Okay, so these are the sums of all my digits. Now, for 3, the sum of the digits is divisible by 3. 15 is divisible by 3. 18 is also divisible by 3. So far, all of these are divisible by 3. Let's check for 6. If the sum of the digits is divisible by 3 and even, okay, that knocks out B because B is not even. Now let's check for 9. If the sum of the digits is divisible by 9. 15 is not divisible by 9. I cannot do 15 divided by 9 without having a remainder. But 18 I can. So that means C is my correct answer. All right, we'll go over the practice problems together in class and do a little bit more division as well as checking for divisibility rules. Thank you so much.